In this lesson, we're going to look at scatter plots. Specifically, you want to be able to answer the question, how do I determine the type of correlation between two sets of data? And then secondly, how can I use a best fit line to model the trend in my data? So let's establish what a scatter plot is. It's simply a graph of a set of data pairs where we have a bunch of ordered pairs where x is one variable and y is a different variable, and we want to notice what type of relationship exists between x and y. So you should know that there are three types of correlation. The graph on the left is modeling a positive correlation. If you've sketched what's known as a best fit line or a line of best fit, it would be a line where about an equal amount of your points are above and below the line. The second graph, the one in the middle, shows a negative correlation, and we would have a line of best fit with a downward slope or a negative slope. The third case is where we have no correlation at all. You can't even draw a line of best fit because there's no obvious trend in the data. Now, with positive correlation, that's as your x variable increases, your y does as well. Whereas in a negative correlation, as x increases, y decreases. And in the last one, the points have no obvious pattern, or we could say that x has no effect on y. So in this graph here, it says describe the correlation shown by the scatter plot. So you want to start by reading your labels on your x and your y axis. So you should definitely see an upward trend here. If we were to draw a line of best fit, probably look a little bit like this. I probably have mine up just a little bit too high. You want to shift that down just a little bit. And what I notice here is that as the subscribers increase, the cellular surface regions increase as well. So this is modeling a positive correlation. So again, as the number of cell phone subscribers increase, the cellular surface regions also increase. And if you think about it, that's logical. The more people who are using phones, you have to have mobile phone companies to support them, so they expand their service. So what type of correlation would you expect there to be between these two variables? So with exercise, I always do this. I use arrows. I say, so as x increases, what would I expect to happen to the weight? So as the time I spend exercising would go up, you would expect that weight would start to decrease. Now, occasionally I have somebody that would argue with that and say, well, you start building muscle mass, but think about it this way. You're looking at overall trends. So imagine you take a large group of people and start making them exercise. I think you would notice that weight would start to decrease. Therefore, that would be a negative correlation because one variable goes up, the other goes down. Notice the explanation here. Right? The second one, age between birth and 12 years old. So again, as the age would increase from birth to the age 12, what would I expect to happen to the height? Well, most kids grow taller between those ages, so I'm expecting that both variables increase. Therefore, this would be a positive correlation. As age increases between birth and 12 years old, the height increases as well. Now, so far that should just be a review of previous content, but something you may not have heard of before is a correlation coefficient. This variable, we usually use an R to represent it, is a number between -1 to 1. And what it does is it measures how well a line of best fit actually fits a set of data pairs. So it's on this continuum between 1 and -1. Very rarely is it ever equal to 1 unless it's exactly a linear equation. Often, it's a very strong correlation would be if your points are really, really close together. The closer those points are together, the closer to 1 it would be if it's positive. Now, on the other end of the spectrum, exactly -1 would be a downhill exact linear equation. But getting close to 1, like maybe 0.9, would be points that are really, really close to one another and definitely have a downward trend. This would show a strong negative correlation, where this would be a strong positive over here. Often it's some decimal in between 0 and -1 or between 0 and 1. If the correlation coefficient is 0, there is absolutely no correlation at all. So it's a way of measuring how strong your correlation actually is. And I will show you eventually on the graphing calculator how it can do that part for you. In the graphs on these three examples, you're asked to express what you think the correlation coefficient is. So when I look at A, at first I kind of got to look rather hard to really see what the correlation coefficient is. And to me, it kind of seems like maybe there's a downhill trend here. So if there would be a downward trend, that means that my correlation coefficient would be negative. And it's not very strong, so I'm going to say that this is closer to negative 0.5. 0 would mean it doesn't exist at all. Negative 1 would be very strong. So this is a weak negative correlation. Now, for graph B, I wouldn't say that there's any trend in this graph. So my correlation coefficient is 0 because there is no correlation. In the final one, it looks to me like there's a definite positive trend. And it's pretty strong, so I would say that this is closer to 1. Please realize it's not equal to 1 or it would be exactly linear, but there's definitely a strong positive correlation shown in this graph. Now let's go through an example where we actually find the scatter plot and the equation of the line of best fit. The table shows the number Y in thousands of alternative fueled vehicles in the U.S. X years after 1997, and we're supposed to approximate the best fitting line for this data. So I'm going to start by constructing a scatter plot to see if I notice any trend in my points. So along the x-axis, I'm going to put the year since 1997, and along the y-axis, I'm going to label this the number of alternative fueled vehicles, and this would be in thousands. All right, so along the x-axis, I'm going to number this as 1, 2 through 7. So 0 would be the year 1997. Now, along the y-axis, I notice my smallest and my greatest value, 280 and 548. So I'm going to put what's known as a break in the scale because I don't have anything until 200 and some. So I'm going to put a little break in the scale, which is going to allow me to start my numbering at something higher. So I'm going to choose to start at about, I'm going to do 225 and count by 25s. So the next one would be 250. And then 275, here would be 300. And I'm going to continue counting by 25. So here's 350, 400, 450, 500, 550, and here is 600, and I don't need to go any higher than that. And then what I'm going to do is simply plot my ordered pairs. So 0, 280. It's going to be a little higher than 275. You're doing a little bit of estimating here. 1, 295. 2, 322. 3, 395, 4, 425, 5, 471, and 6, 511, and 7, 548. Now, I'm going to draw my line of best fit, which, as I do this, is really more of an estimation right here, and you want to get it so all the points are about an equal distance from that line of best fit. So I'm going to go with something like this. And what I want to do is figure out what is the equation of this line of best fit. So the next part of this process is simply estimating 2 points that you think fall exactly on this line. And what's important is it doesn't have to be 2 points in the table that were given to you. So when I look at this, I'm going to put this green point here, and that looks like the point 2, 350. And then I'm going to use another point. I'm going to say it appears like there is one at about right here, which is, I'm going to call that 6,498. Now this is where when you approximate a line of best fit, because if your line of best fit might be a little bit different than the person next to you because you're choosing 2 points that fall on that line. But what is important is you must choose 2 that fall exactly on that line. So to find the equation, you need your slope and your y-intercept. So pause the video and calculate the slope between these 2 points and then press play to see if we agree. So I get 148 over 4, which reduces to exactly 37. And let me tell you that that's a little bit unusual. I'm getting lucky here that this works out to a nice whole value. Often you're going to get an odd decimal when you're dealing with real life problems, and that's completely normal. So I get a slope of 37. I'm just going to go with that. And I need to find my y-intercept. So I choose one of those ordered pairs. I'm going to go with the 2, 350. Again, pause the video and find your y. Or find b rather, not y. So you're plugging in 350 for the y equals, I'm using the slope I found, 37 times 2 plus b. So I get 276 equals b. Therefore, the equation of my best fit line would be y equals 37x plus 276. Now, we'll have a discussion about whether this is really the best fit line, because if I had chosen 2 other points, it would be different. But the final question here is use this to predict in the year 2010 how many alternative fueled vehicles will be on the roads. So all you're going to do is plug in, don't plug in 2010 for X, but how many years would that be since 1997? So if you do 2010 minus 1997, that would be 13 years. So you're going to plug in 13 in place of the X and calculate that. And I get in the year 2010 there would be approximately 757,000, make sure you put that 1,000 on there, alternative fueled vehicles. So we will look at how to find the equation of a line of best fit using linear regression on the calculator shortly.